So a marksman's chance of hitting a target with each of his shots is 60%. If he fires 80 shots, what is the probability of his hitting the target at least 30 times, fewer than 25 times, and between 15 and 45 times inclusive? Well, as you can see here, I mean, one of the reasons why you may want to do normal approximation is because if I'm looking for the probability that he's hit the target at least 30 times, then I have to do the probability of 30, 31, 32, 33, all the way up to 80, which would be a lot of probabilities to calculate using that binomial formula. Or I could do 1 minus the probability of 0 through 29, which again is not much better. That would still be 30 calculations I had to do to get the probability that I need to answer this question. So using a normal approximation or using a normal distribution to approximate this is certainly going to streamline things a bit. And so if I look at this really carefully, right now, the probability of success is 0.6. 0.6 times 80 is 48. So n times p, which that's my mean, is 48. That's well over 5. And if I look at nq, which would be 0.4 times 80, I would end up with getting like 32. That's well over 5 as well. So this is sufficiently big enough for me to use the normal distribution to approximate this, which makes things a lot easier because I'm going to calculate the mean standard deviation. Well, n times p I kind of already figured out was 48. The standard deviation, I do 80 times 0.6 times 0.4 and square root that, so I end up with the square root of 19.2. And I'm going to keep it like that for the time being because, it's not really a nice number to deal with. It's irrational, and I'd have to round it, and I try to avoid rounding as much as I can. So we'll find the probability that he hits the target at least 30 times. So I'm looking for the probability that x is greater than or equal to 30, which would be 1 minus the probability of x is less than 30. Again, I'm going to a less than mostly because of the fact that I know that the table primarily deals with, less thans. I could also just kept it the way it is and then gone with that. But again, I'm kind of handling the equal to part nicely here because, I want to make sure that, that this is the exact opposite without the equal to. So the probability of x is less than 30 would be the probability that z is less than negative 4.11. Now, if you look at the table does not go up down this low for a negative 4. I mean, so they basically usually tell you to assume 0.0001 for this, but it's actually beneath that. So so I'm going to say the probability is about 0.9999. And, since, it makes sense because I expect to hit it 48 times. So, I mean, it's almost certain that I'm going to hit it at least 30. Of course, it'd be a rare occasion if it didn't. So, if you want to say it's more than that, if you want to say it's approximately 1, that's also okay, too. But basically, it's almost certain that this marksman is going to hit it 30 times or more. Fewer than 25 times, again, I'm going to do the probability that x is less than 25, which basically is the probability that z is less than negative 5.25. And again, it doesn't go down that low. So, I know it's going to be less than 0.0001. So that's about nothing. So there's basically no chance that this marksman is going to hit fewer than 25 times on average. Okay. Between 15 and 45 times inclusive. For these kind of distributions, there's a way of handling that in the realm of statistics. We're not going to get into that so much in this one. But between 15 and 45 times would be the probability that, x is less than 45 and p is minus the probability that x is less than 15. The equal to parts with this many numbers doesn't really matter that much. It's a very insignificant difference. So, and again, the probability that x is less than 15 is that z is less than negative 7.53. So this is basically 0. I could probably say, okay, this is nothing. I'm gonna look for the probability that Z is less than negative 0.68. So I look that up on the table. I get about 0.2483, of course, minus 0. So about 0.2483 is the probability of the marksman hitting between 15 and 45 times. We expect him to hit it more than that. So